And now, to explain any given amount of impatience, delta is just not doing nearly as much of the work. And so most of the discounting has to be coming from beta. For delta to explain both this trade-off and that trade-off, the short-term trade-off must be mostly driven by beta, because delta just can't be that low if it's also going to explain these trade-offs. So what that means is that beta basically has more impact on your intertemporal choices when the delayed outcome is in the relatively near future. And if we push the delayed outcome way into the future, 10 years out, beta just doesn't have as much of a role. The delta discounting, the exponential part of the discounting, dilutes the effect of beta. Okay? So to see whether or not you understand that, a clicker question. What would the regression line look like, this line, in particular its slope, look like if we excluded time horizons less than 1 year, and what would that suggest about intertemporal preferences? Okay? Would it get steeper or flatter? Okay, so I say flat, but I really mean flatter. Would it get steeper or flatter, and what would that suggest about people's degree of patience or impatience over time? Again, you can discuss that amongst yourselves if you want. Okay, let me give you about another 5 seconds. 5, 4, 3, 2, 1, and let's see what you guys said. All right, modal answer quite strongly is C, which says that it would be, the regression line would be flat or flatter, suggesting that people are patient so long as there are no payoffs in the present. Okay, so somebody other than Andrew who said C, want to explain that? What's going on here? Careful if you run your hands through your hair, I'm likely to fall on you.
So if you ignore the points at the very beginning,
yeah.
So first of all, it has sort of an issue characteristic, but once you those points, then the remaining lines basically, they visually appear kind of close to 0.
Okay, so that part's straightforward. And the question is, how do we interpret that in terms of people's patience versus impatience? So what does flat line mean here, right? So this is the per period discount factor delta as imputed by trade-offs with increasingly delayed rewards. So what does that being flat tell us?
That the discount factor is very low if at all. And
the long-term, the sort of long-term patience thing is people are relatively patient. That's because all those numbers are pretty close to 1. Okay, and then presumably that what you're saying is that so long as there are no payoffs in the present. So then when you add in the ones that are in suggesting that people are patient so long as there's no payoffs in the present, because basically what's going on is that these numbers here are situations where, again, most of the discounting is being done by delta, right, which suggests that the long-term patience is relatively high. These are ones where beta is doing most of the work. Now, beta is involved in all of these ones as well, but these are the ones where beta is doing most of the work, which suggests that beta is relatively low, which is to say that people are impatient when there are payoffs in the present. Okay, good. Okay, so we've referred to this slide. I was going to do a bunch of math. I'm willing to post that math online, but for the sake of getting where we need to get by the end of today, I'm going to actually not do this in class today. So now let's move on to this issue of beliefs and predictions. Okay, so we're back into the realm of rational expectations versus irrational expectations. So expectations are about what do you predict will be true in the future, what do you believe will be true in the future, so we can talk about beliefs, predictions, and expectations. They're all the same thing. The beta-delta model is incomplete because it doesn't yet, it is incomplete as so far, because it doesn't yet tell us anything about people's beliefs about their future self-control problems, the self-control problems that they will have in the future. And as a result of the model being incomplete, the predictions of the model are uncertain. And we've seen that before with reference dependence, that until we had some way of specifying what the reference point was, the predictions were ambiguous. And as soon as we were willing to go on record and say, the reference point is derived from your expectations, the reference point is derived from social comparisons or something like that, the predictions are ambiguous, because the predictions would change depending on what reference point we put in. So what we're going to find here is that depending upon what assumption we make about whether people accurately foresee their future present bias problems, we're going to get different predictions. Let me give you a simple example. So this is one of these little Rabin-esque toy models that I've talked about, and this one comes in particular from the O'Donoghue-Rabin paper that's assigned, I think, for this week, which is called Doing It Now or Later. So this is a study of how present bias preferences affect decisions of the type where there's something you've got to do one time and you have to decide when to do it, now or later. Okay, so this could be about something that you're tempted to do now, like in my case recently I was faced with an extremely challenging decision of when to eat my girlfriend's sugar-free apple pie. And you'll be amazed to know that the answer included 3 different days, only one of which at any point in time was now. I was very proud of myself. Or it could be something that you don't want to do, something aversive that you'd rather procrastinate, potentially. So here's a setup in which it's something that you don't want to do, right? Which is a decision of when to do a problem set. Now, obviously, Matt Rabin, at the time that he wrote this paper, had not encountered one of my problem sets, which of course you would want to do as soon as possible because they're so enjoyable. But we have a setup here where you're doing, like, let's say, one of Matt Rabin's problem sets, which I've done a number of, and they're hell. And the choices are you can do it in period 0, period 1, or period 2. Now, for simplicity, I'm going to assume that those are Friday, Saturday, or Sunday. Okay? And the setup is this. Each day there's a different movie. So maybe there's like some movie festival going on, a film festival. And doing the problem set means missing the movie. Okay, so you work all day, you're going to do the problem set in the evening, there's a movie each evening. You need one evening to do the problem set, which means that the problem set imposes a cost on you equal to the utility that you would have gotten out of going to the movie. So the setup says that this is the value of the 3 movies, so they are in ascending order of quality. That's what you would expect in a film festival. In the paper, as you'll see, they are described as the fair movie, the good movie, and the Johnny Depp movie. This is because Matt Rabin is obsessed with Johnny Depp, and unabashedly so, and I think probably appropriately so. And, you know, it all depends on how you feel about Johnny Depp. So what happens here is this. Now we're going to make some assumptions about preferences, right? This person has a beta of 1/2, so that's a pretty extreme short-term discount factor. Actually, there are estimates in literature that low or close to that low, but we're going to make it 1/2 for obvious simplicity reasons. And we're going to assume that delta equals 1. Now we're going to assume that delta equals 1 in almost everything that we do in terms of problem solving and simple models and simple examples. And we like doing this because it makes the math simple, and simple math makes it easy to get the intuitions out of the model. We're going to be okay doing it. We're going to justify this choice because the time periods are going to be very short, right? So delta in this case would be a 1-day discount factor. And we know that in any sane, reasonable model of exponential discounting, of the exponential part of our discount function, the daily discount factor has just got to be very, very, very close to 1. Otherwise, you would basically jump off a bridge just for the pure thrill of the first few seconds. So we're just going to allow ourselves to set delta equal to 1, and that's going to be fine. So all of the work here is on beta, or is being done by beta. Now, let's start with a question that is unambiguous and doesn't depend upon this person's predictions about their future preferences. Suppose that on Friday, this person can perfectly commit to doing the problem set on any date. So this is a student, for example, who can call out a hit on herself, conditional on whether or not she does the problem set when she says. Okay, so she can get Guido to come and force her to do the problem set when she specifies that she wants to do it. So let's find out what day she would write in that contract with Guido. Okay, so from the perspective of her period 0 self, which I'm just going to call self 0. If the problem set is done, so from the perspective of Friday, her Friday preferences, if she does it on Friday, she's going to miss a movie worth 1 euro. Okay? If she does it, the problem set in period 1, from the perspective of Friday, she knows she's going to be missing a movie worth 3/2 of a euro, 1.5 euros, but she discounts that by 1/2. So the utility loss she feels on Friday from a plan of doing it on Saturday is 1/2 times 3/2, which is 3/4. Okay? And similarly, if she does the problem set in period 2, if she writes period 2, she writes Sunday on her Guido contract. From the perspective of Friday, the utility she places on that plan is she's going to lose 5/2 from missing the Johnny Depp movie, but she's going to deflate it so that on Friday that only feels like 5/4 of a euro loss. Okay? And then you can just rank those things, right? We want the smallest number because this is a cost, and so she's going to say, I want to do it on Saturday. Okay? If she can commit, that's the choice she'll make. Yeah? Now, the question that we want to ask ourselves, no, we don't want to ask ourselves just yet. Yeah, we do. The question we want to ask ourselves is, what if the student can't bind herself on Friday? Okay? Which is the usual situation, at least on this side of the Adriatic. So what happens? At time 0 on Friday, she wants to do the problem set on Saturday. But the question is, would she actually do it on Saturday? So we're going to now go forward in time and ask her Saturday self what her Saturday self would like to do. From the perspective of Saturday, period 1, if the problem set is done in period 1, then I call this the discounted cost, but now the Saturday self isn't discounting the Saturday movie, right? That movie has become tempting. On Friday, it wasn't tempting because it was in the future. I can exert all kinds of self-control over things that I'm not tempted by. But when Saturday comes, all of a sudden the good movie becomes tempting, but I'm still discounting the Johnny Depp movie on Sunday because it's still out there in the future. So I would now prefer, right? So now missing the discounted Johnny Depp movie hurts less from the perspective of Saturday than missing the good movie, which is tempting and I'm not discounting. Okay, so she prefers to put the problem set off to t equals 2. So we say that the student's preferences are dynamically inconsistent, and it results in a dynamically inconsistent choice, right? So in particular, what's going on here is that on Friday, her preferences for Saturday versus Sunday, right, are both discounted. Her utility for Saturday versus Sunday are both discounted by beta. So her preference between the two doesn't involve this impatience. When she gets to Saturday, all of a sudden she's discounting Sunday but not Saturday. So her preferences between Saturday and Sunday have changed. All right, and as a result, her choice has changed as well, and she's gone from preferring Saturday to preferring Sunday for when to do the problem set. Okay, that's not in your handout, is it? Good, because I don't want it in your handout. I want you to draw it in your handout. So here's a tool that we can use for helping us to figure this kind of problem out, and it's called a table of utilities. At least it is in this room. Now, I believe that this is a device that was invented by Wotan Kosegi, from whom I inherited this class, and I like it, but it has limits, and so I'm going to use it for this simple example, but I want you to be careful about using it for the more complicated examples that we're going to see starting on Thursday and in the problem set. So the way it works is this, okay? This person faces a choice, let me do it here, faces a choice of when to do the problem set, and her choice set includes do it on Friday, do it on Saturday, do it on Sunday. Now, the crucial thing for you to understand is that these columns in a table of utilities always represent her choice set. Right? In this case, the choice set looks like it is when to do a task that has to be done in one period. But in other models, in other settings, the choice set might be should I or should I not go to the gym next Friday? Okay? So that the columns would be go to the gym next Friday, don't go to the gym next Friday. Okay? And then this column is going to be we're going to fill this in with utilities. And so what we want to know is utility from what perspective? Okay, so first we're going to look at the instantaneous utility, which is the sort of perspective of someone who doesn't do any discounting at all. So you might think of this as, before Friday. If you were asking this student previous Friday, her preferences would basically be driven entirely by the instantaneous utilities. Okay, so this is undiscounted utilities. And in this case, those are given: 1 for the movie on Friday, 3/2 for the movie on Saturday, and 5/2 for the movie on Sunday. Then what we want to know is, what is the utility of any of these different choices in her choice set from the perspective of her Friday self, from the perspective of her Saturday self. Okay, and in this case, we're not going to care about her Sunday preferences. Does anybody see why? She has no choice on Sunday. If she hasn't done the problem set by Sunday, she has to do it on Sunday. Now, this is by that we can know that this is a model of a Cal student, because there are plenty of universities, including the one that I attended for the first 2 years of my college experience, where an additional option would be to never do it. But you guys would never think of that, I know. So what do we have? From the standpoint of her Friday self, she doesn't discount the movie on Friday. She does discount the movie on Saturday, and she does discount the movie on, sorry, that's supposed to be 5/2. This is supposed to be 5/4. That's what happens when you put down your notes, Dr. Eklund. From the standpoint of period, the order, the rank, no, the undiscounted rank, which you might think of like as the rational preferences, right? Preferences that don't involve this problematic present bias. Whether or not we should think of that as rational is a big question that we'll get into next week, I think. So her preference ranking goes like this: 0, 1, 2. That's sort of like her rational preference ordering, right? You should do it on Friday. Your preference should be first Friday, then Saturday, then Sunday. From the perspective of Friday, because she has present bias preferences, this one jumps up in the rankings. This one jumps up in the rankings, and her preference ranking is do it on Saturday, then Friday, then Sunday, right? In terms of the order in which she prefers these things. From the perspective of Saturday, of course, she no longer has a Friday choice to make. That choice has been made. So under the assumption that she didn't do the problem set on Friday, she no longer discounts the Saturday movie. She does discount the Sunday movie, and the ordering now between 1 and 2, 0 is no longer possible, and the rank has changed again from Saturday being preferred to Sunday being preferred. So there's no content in this that isn't in the previous slide. It's just a way of representing it that makes it a little bit easier to figure out the answer to the problem. So instantaneous is if beta was equal to 1. So if we think of beta, if we think of present bias preference as being a form of irrationality, and I hope I convinced you that at least in technical terms it is a form of irrationality because it introduces preference reversals. It doesn't mean that you're insane if you do it. You might or might not be. But because it introduces preference reversals, in terms of the technical definition of rationality, it's a form of irrational preferences. Then we can think that the instantaneous utilities in some sense capture the rational preferences of this person if they didn't have present bias. And there was a question in the front row. No, you're cool? You got it? Okay. So the point here is that what is the point? Yeah, okay, so here's the issue, right? I said that the model is ambiguous. The question that I want you guys to think about here real quickly, on your own, this shouldn't take long, given the time-inconsistent preferences that we've seen in the last two slides that I've represented here, when will the student actually do the problem set? Okay? You've seen what her Friday preferences are, you've seen what her Saturday preferences are. When will she actually do the problem set? Now, you can see that the answer is going to be that you don't have enough information. The question is, what additional information do you need? Do you need to know whether she predicts her future preferences, whether she can restrict her choice set, or whether she has rational expectations? So just think about that yourselves quietly for a moment. Okay, 5, 4, 3, 2, 1. Okay, we're good. All right, we have a bunch of B's and some A's and a few C's. Anybody, A, B, or C? Turns out there's more than one right answer here. You chose B? So you're saying she needs, if she wants to do something other, so the problem she's going to have is that she's going to procrastinate all the way to Sunday and miss Johnny Depp, right? Now, if you're Matt Rabin, this isn't a problem because he probably has a slew of Johnny Depp DVDs. But so you're going to procrastinate. That's the problem. You're saying the only way that she can solve that problem is if she can commit to doing things on Saturday. And so if she can't bind herself, if she doesn't have a Guido, she's stuck. And then what are you saying about whether or not she can predict her future preferences? That doesn't matter? So if she can predict, then she can foresee that she's going to procrastinate, and then maybe she can make the choice to bind herself in some way. So both A and B need to be true. Anybody else want to chime in on that? Rational expectations. Oh, so you're saying rational expectations is whether or not she even has present bias? Okay, so what we're going to see is there's a difference between rational preferences and rational expectations. Rational preferences is whether or not you have a beta. It's going to turn out that rational expectations is whether or not you predict that you have a beta in the future, a beta less than 1, which is A. So it's going to turn out here that C and A are the same question. Because in this case, rational expectations means do you correctly predict your future preferences? Okay, so beta is a preference parameter, in the same way that the loss aversion parameter was a preference parameter. Beta tells us your preferences between now and the future. The question is, I know that I have a beta less than 1 right now because I can feel my preferences. I know that I'm tempted by the Friday movie. The question is, when I think about the person I'm going to be on Saturday, do I predict that I will also have a beta less than 1, that I will also have a self-control or a temptation problem on Saturday? Or do I do this thing where I sort of say, well, I really want to procrastinate tonight, but tomorrow it's not going to be an issue, right? Like, no, Mom, I don't want to clean up my room. I'll do it tomorrow. And Mom's sitting there going, I know what you don't know, which is that you will still be the same whiny little kid tomorrow that you are today. So therefore, I'm going to, eat you with a foam noodle until you clean your room. That's the Guido contract. Don't do that. Now, this issue of whether or not she can restrict her choice set is going to be interesting. Remind me your name? Henry. What Henry said initially was she's only going to be able to change her future behavior if she can bind herself in some way, and then she will need rational expectations in order to even want to bind herself, right? Because if she thinks that her future self will clean the room, will do the problem set, there's no reason she doesn't think she has a problem, so she thinks, yeah, I'll follow through. Okay? But it's going to turn out that it doesn't actually always depend on whether or not she can bind herself. That there are going to be situations, and naturally this is one of them, where she has a way to fix her problem without coming up with some sort of external commitment device. So let's take a look at that. All right. So the solution to the fact that the model is incomplete is to introduce two new concepts, naivete and sophistication. I will tell you one of the most annoying things about being a behavioral economist whose primary interest is in intertemporal preferences is that little diacritical and that little diacritical are annoying. So I'm, for the most part, going to just leave them out. And then when you get around to publishing in peer-reviewed journals, you have to put them back in. So what do I mean by this? So the answer here, as we've already discussed and probably is obvious, is that it depends upon the student's beliefs about her future and patience. Okay, so let me see. Right, so